Hello guys, today I will be going through my project sentiment analysis. We'll be analyzing if a customer review is positive or negative and then classify them using machine learning model. So this is a simple project. We'll be going through the code walkthrough. So we'll be importing our basic libraries, NumPy, Pandas, Matplotlib, Re, NLTK, sklearn. So these are libraries that can be used for machine learning data science projects. So NumPy's Pandas are for like data manipulation, NumPy is for numerical pandas to store in data frame, Matplotlib tool, and Seaborn for like visualization, Re for regular expressions, NLTK for it's like for NLP package that is used for text processing, and sklearn is for machine learning related models, tasks, and all. So first step first, we import all the necessary libraries. Not much to go there. So second, I forgot to mention, we are using Amazon customer review dataset. I provided the Kaggle dataset link in this notebook as well. So the file has like two datasets. One is already trained, one is test CSV. So the dataset only has three columns in them, and then the three columns are like polarity, title, text. So polarity means they've given the score, is it a negative or a positive. So one for negative, two for positive. We have title, the actual review heading you see on Amazon, and the text, the thing that people has written. So basically three columns. So it's a simple data set, but yeah, it does some pretty impressive job in conducting sentiment analysis. So first thing first, we'll import the data set. We're importing the train.csv. We just took a look at it. We don't see any header over here. So we'll do some basic EDX because this is a simple project, and then we only have three columns, so not much to go through, but obviously there's many things if you really want to explore the data. So we'll first thing first, we'll add some headers. So this must be the polarity, this is the title, this is the text. Then we'll check the data set, how big it is, the shape of data set, and then we'll see. I think it's good if we drop the title column as well, and then other basic steps like checking for null values. We can check for the ratio of positive and negative reviews in our data set. We can also check the top positive word, top negative words. There's many other explorations we can do as well. So I've just done basic to like go through this and go through the process. So we're checking the shape of data set. It's like ones, tens, 100,000, 10,000, lakh, 10 lakh. Yeah, so around 36 lakh rows and three columns. So that's a lot of rows. And then so for the sake of this purpose and to train the model in much faster way, I've reduced the number of rows to 1 lakh, 1, 10, 100,000, 10,000, 1. So just to reduce the size of data set, you can go ahead train with the entire data if you want. So yeah, so I've added the column headers again. So we saw earlier it's 0, 1, 2. So we've added polarity, title, preview. So from here, I think title is not that much needed because the review will actually contain the actual sentiment analysis. So if you want, you can use title also, but I think it's okay if we don't use it. You can obviously conduct PCA and other methods to determine correlation metrics or anything to determine the importance, but yeah. So we'll drop the column, and then yeah, we're checking for the null values over here. So literally no null values. So this is a good data set, I must say. And then we'll say we'll check the polarity. This means like we'll see, yeah, the number of negative reviews are 0.51, the positive reviews are 0.48. So it's around the same. Let's say 0.5 each. And then what we'll do is we'll pre-process the data. So here we'll use the NLTK library. So first thing what we're doing is where you can see the data, if you can see capital letters. So we're removing the capital letters. we're removing the links, HTTPS, we're removing the special characters in it, and then we'll tokenize it to stop words, and we'll obviously do stemming. So we're removing the links, we're special characters we're removing, we're removing the stop words as well, and then we're applying the stemming process also. So we're basically reducing the words to the root words. So now once we've defined this process function, so we'll apply this into our data set. So we're applying this into our data set. I tried it with the 36 lakh rows. It took some time in my motion, so I was actually running this in my in Google Colab. So I ran out of the runtime issues, so I've reduced the data set. That's why. So it happened once you see the words have become smaller, lowercase, sorry, and then you see it has removed some stop words. This soundtrack was beautiful. It's been soundtrack beauty paints, and so yeah, it's done its thing. So once that is done, we'll be using again TF-IDF vectorization. So this is term frequency inverse document frequency. So what we are doing here is we're checking for a term in the frequency of a term in the entire document. So this will help us turn this into a numerical features for this same text. So our machine learning model can be trained on that numerical values. So there are other methods also to do. There are other approaches also, bag of words, but TF-IDF is better, like because it weights in terms of importance, because the number of time word is coming or not. It improves classification and prevents overemphasis in frequent words. So yeah, we prefer this method. And once that is done, we'll be training the model using linear SVC. It's a type of SVM model. It comes under SVM model. So it basically happens that it makes the optimal hyperplane which it can which divides the data set into and classifies it. It's basically like a let's say in a quadrant space, it will create a hyperplane or like a line that divides the yes and no values, the line. So anything above that line will be yes, anything below that line can be no. So once that is done, we'll be using TF-ID vectorizer variable where we'll be calling this function, and then we're adding the features. Normally 10,000, you can keep it 5,000 or anything. So and then n-gram range 1 to 2, consider both like single words and pair of two consecutive words, and then term frequency scaling for sublinear. Once that is done, we'll call that function in our dataset review, and then we'll train it in our polarity. After that, we'll call our linear SVC model. So we've used C equals to 0. It's a regularization parameter to prevent overfitting. Uh, and then max iteration 2000, the number of iteration for optimization algorithm. So once that is done, we'll fit the model, train the model. Now we've trained our model, so we'll need to obviously test our model, how it's performing. We'll need to evaluate. So for that, we'll be importing our test data set. So yeah, we check the shape. It's around 4 lakh, 1, 200,000, 10,000 lakh. Yeah, 4 lakh data set. So since our test data was 1 lakh, I reduced it to 1 lakh to create it like 50-50 type. So yeah, again the same thing. We've added the column titles, then we've dropped the title column, and then we're again pre-processing the data, again calling the same function we declared earlier. And once that pre-processing is done, we're again vectorizing our test data set, and then we're testing it using our model. So the evaluation we got here was we printed a classification report. So the accuracy we got here was around 0.86, and you can see other metrics also: precision, recall, F1 score. So we've also printed the confusion. We can say 86% accuracy. It's not bad. It's okay. So if we train it with entire data set, we might achieve more accuracy. We can do some hyperparameter tuning as well. We can apply a grid search CV as well. There's many in this possibilities we can do to improve our accuracy. For now, I'm happy with 0.86 for the purpose of this project. And then we've also created the confusion matrix here, so you can see the number of actual positive values and the predicted positive values come around 6,000. Sorry, positive, yeah, positive, positive, yeah, comes around 44,000, which is not bad. And then again negative and negative, like true predictions are coming much higher than the wrong ones, so not bad. Once that is done, we'll also calculate the ROC curve. You can see here, so the ROC curve area comes around 0.94, so which is not bad. So we should be aiming later for one in that shape. So again, yeah, we can do the methods that I've said earlier to increase the ROC curve as well. So we're also going and saving our model that we have trained using joblib. So I prefer this can later be used by the backend team to create a Flux application or web application or ML or any mobile application. We can use this model later onwards for deployment purpose or development purpose. So yeah, we've run some predictions in our model as well to just go through it, test it. So we've like predicted with this game has to be the worst game I ever tried. It constantly crashes and glitches. Yeah, it's gone negative. So it classified it correctly. The product quality exceeded my grade value for price positive, negative. I had high hopes after it, but this were negative. Yes. So we can see it's predicting pretty good. So yeah, this was my sentiment analysis project code walkthrough. Thank you.